Okay, so I want to show you one thing I'm not sure if you're aware of, but when you're watching a video, it shows up as a mashup, and the reason I showed it as a mashup is just if you're working in the background, you can look at it. So this PDF's the one that I emailed you was this today. But when you hit play, you can make it full screen, and it take over your whole screen.
And then example 210.
This should.
So I'm going to start again with my chart.
It clears in after just a second, if I'm not mistaken.
So I'm going to go ahead and dive right into it.
Yeah, that is kind of hard to read.
It gives us void ratio,
so it clears up after just a few minutes.
VV over VA.
Okay. So just wanted to show you that real quick. And if you needed to do that. But I emailed that to you. Alright, so we're going to get started. Let me get my... this is the PDF that I emailed you. This is an older textbook. But it's exactly identical to the new textbook. It's just got some different pages. So if you have your new textbook, it's on page 19. But you can... I've got the PDF so you can look at it. So here's our equations here. Now, the terms are right up top for you if you want to read over those if you're not sure about them. So these are our basic formulas that we use. The void ratio, porosity, degree of saturation. So you noticed I lined through these equation numbers is because your textbook, that's equation 2728. So I wanted it to had the same equations as your textbook. So degree of saturation, water content. This is unit weight, which is the total W over V. This is dry unit weight, which is your volume of your solid over void. And then here's the mass formulas, but with us, everything I think that we're going to have, you're going to have on a test or have to do, it's not dealing with mass. So also today, in one of the problems, we're going to use this equation 213. That's just a rearranged formula of this volume over solid formula. In other words, it's bringing the volume of solids over here and then bringing the volume of the solid. So in other words, it's rearranged this formula if you're solving for the specific gravity. So it's just this formula rearranged, but it's one that I like. Alright, so the other things you need to know are that the unit weight of water, and it says it's around 62.4 pounds per cubic foot, or 9.81 kilonewtons per meter cubed. These are both the weights. This is all that we're going to deal with. We're not dealing with mass, so you don't need to know 1,000 kilograms. So we're going to work with weights. Alright, so I'm going to work the one that's 100% saturated. So that will be example 2.9. Alright, so I want to show you, if it's 100% saturated, it means there's no air. So this air that was on the top has been completely, you've put water on it, you stirred it, you've gotten rid of all the air in it. So the only thing you're left with is water. So I'm going to be working this formula, and I'm going to work it over here on the weight mass. Alright, so we're in this one, we're given that it weighs 120 pounds per cubic foot. So that's your total weight, and this is 120. Let me rewrite that one. I'm using a different pen today. So the weight is 120 pounds. Okay, and you're given the water content. So we're given a water content, and that's all that we're given. They want void ratio and specific gravity of the solids. So I'm going to go ahead and roll down. And we're given water content. So water content is equation 210. So it's WW over WS. So I'm going to write this as equation 210 times 100. And we were given that, and that's 36%. Okay, so now if I solve for WW, we're going to divide each side by 36. 100. So that'll be WS equals 0.36, because all I did was divide 100 to get rid of it on this side and divided the percentage by 100. Now I have the weight of the water equals 0.36 WS. Alright, so we also know based off these formulas, so let me go back up, because these formulas are not in the book. But if you want to write them down, you always know that the weight of the air, the weight in the water, and the weight of the solid has to equal W. And air doesn't weigh anything. So right now I can say WW plus WS equals 120. Also, on this left side of the block diagram, VV and VS have to equal volume. Also, there's a formula for the volume of the solids, and that would be equal to the weight of the solid divided by specific gravity of the solid and unit weight of water. So there's not an equation for that, but it's in the block diagram, and that block diagram is in it's in your book on page 19, and it's also part of this PDF. It's back up right below the formulas. All right, so so there's two, and there's another formula doesn't have an equation number, but it's volume of water equals the weight of the water divided by specific gravity. Unit weight of water. Weight of water divided by unit weight of water. It would be specific gravity, but specific gravity of water is 1, so that's why they don't put it in there. Now, if something is 100% saturated, and this one is, that means there is no air. So I'm going to go ahead and roll through that, because we don't have any air. Because it's all been filled with water. So we've got a lot of water in this one. So what they did is just soaked it in water and stirred it all up and completely saturated it. Alright, so I just kind of want to talk about those. Now I'm going to go ahead and go up. And if we know the weight of the water plus the weight of the solid equals your weight, and that's from the block diagram, I'm going to sub 0.36 WS plus 1 WS should be your weight. And now, if you've got a WS, it's always understood that it's 1. That comes from 171. So you've seen this where you're taking two equations with two unknowns and then solving for one and then subbing it into a second equation. So that's why we use water content, and then now we're using the weight of the solids, the weight of the waters, and the weight. Okay, so we do have a weight this time. So that would be 0.36 WS plus 1 WS equals 120 even. All right, so that would be, so when I solved for that, I'm going to add that be 1.36 WS equals 120 pounds. I'm going to divide that by 1.36. And WS will equal 88.23 pounds. Alright, so if you looked at the book right here, they just rounded it to 88.2. I've got 88.23. So now if I sub that back in, and if I'm looking at my equation here, right here, if I want to substitute that in, we can solve for the weight of the water, because we know the weight of the solid and we know the weight. So the weight of the water plus the weight of the solid equals the weight. Weight of the water plus our 88.23 equals the 120 pounds. So the weight of the water equals 120 pounds minus your 88.23, and that's in pounds actually. So the weight of the water, now I got 31.77 pounds. Okay, so the textbook just used 31.8, so they rounded it up. So I'm doing this example right here that's in your book. Alright, so I'm going to go back up and put these in my block diagram. So we just solved the weight of the solid, and I had 88.23, and we solved for the weight of the water, and I got 31.77. Alright, so that tells me with those two values, I now can solve for the volume of the water using this formula because we've got the weight of it, and I also can solve for the volume of the solid because they gave us the specific gravity. No, they didn't. They want us to solve for specific gravity. So I'm going to have to solve that, and then we're going to have to assume 1 feet cubed, and I'll show you what we're going to do for that. So they didn't actually give you, you were just going to have to assume it's 1 feet cubed. So once we solve, alright, so we're going to solve for the volume of the water. So the volume of the water equals the weight of the water divided by unit weight of water. So volume of, or volume is, that's actually volume of water, sorry. So volume of water equals the weight of the water divided by unit weight of water. So we're solving for that. So the weight of the water is 31.77. That's pounds. This is English, so 62.4 pounds per cubic feet. And that will give us the volume of the water. And I got 0.51. Exactly. Okay. So here's what happened. If it's completely 100% saturated, that means no air. So actually the volume of the water and the volume of the voids are the exact number. They're equal. In other words, because there's not any air. So that means if it's 100% saturated, 100% saturated, that means no air, and VV equals VW. So knowing that, I can look at my formula. For the volume equals the volume of the voids plus volume of solids. I'm going to go ahead and put my 0.51 up in the top. So right there, I'm going to say that this is 0.51. Now we've got to assume 1 meter cubed. And if we were assuming anything in the two problems, I went ahead and put that in your assignments. The problems you're going to be working will be 2.8 and 2.9 in the end of the chapter. One, I told you to assume 1 feet cubed, and one was 1 meter cubed. So I told you that. But they're both 100% saturated. So that means that 0.51 is the volume of the voids because we have no air. So that actually would be our... I'm going to write that. It's cubic feet. I'm not putting that on there because it's so hard to get it. I just put meters. We're going to assume 1 feet cubed. So as you can see, to solve for the volume of the solids, these two have to equal 1. So I'm going to go down. Plug my numbers in. This is 1 feet cubed equals, we know the volume of the voids because that's the same as the volume of the, so it would be 0.51 plus your VS. So we can 1 feet cubed minus 0.51 equals VS. So that would be VS is going to equal 0.49 cubic feet. So now I have this is 0.49 cubic feet. That's your volume of your solids. We know the weight of the solids because that's at 88.23, and we know unit weight of water. So to get the void ratio, I can go ahead and solve it because I've got those two, but they actually ask for specific gravity as well. So I'll show you the two equations we're going to use. So void ratio which is E, and that's equation 2.7. So I'm write that. So E is volume of water divided by volume of solids. And now remember, this is 100% saturated, so the VV equals the VW. So that would be 0.51 cubic feet, and that would be 0.49 cubic feet. So once you put that in, you should get 104. So the actually void ratio is greater than 1. Everything we've worked before, the void ratio has been less than 1. So if you have that question, and I'm giving you a hint to a test problem, if you have a void ratio greater than 1.1, that means you have more water or more voids than you do solids. So anything that's greater than 1, that means you have more voids than you have solids. And you'll find out when we're doing, in engineering materials, we'll do some where we're figuring out the volume of a bucket and our unit weights. And you'll find out how much air is actually in there, even though we might tamp it down and rod it and put it in layers. We're trying to get rid of the air, but we still have a lot of air and voids in there. Alright, so we just solved for that. Now it wants specific gravity. And this is when I'm going to use the formula that's in your book or on this sheet, which it says specific gravity is. So that's actually equation 215. Says that your specific gravity of the solid equals the weight of the solid divided by the volume of your solid, and then that's divided by unit weight of water. Alright, so this is what they're wanting. So once I plug my numbers in for GS, I had the weight of the solid as 88.23. The volume of the solid is 0.49. Okay. So, well, that's the answer. So it's the volume of the weight of the water divided by volume of your solid, 0.49. And that's all over unit weight of water, 62.4 pounds per cubic feet. And this is pounds. This is cubic feet. So all of this is going to cancel out. And you should get a specific gravity of 2.89. So you were doing specific gravity in last week's lab, so you should kind of know what you're using and use specific gravity, and we were trying to roll it. But here's how you can solve for specific gravity, and that was the two things that they wanted. And they used 88.2 and I used 88.23 to solve for it. And I used the equation that they had, and I came up with 2.89 because I kept my number all the way out. So that's as simple. You should be able to work your two problems now. They were based a little bit like this. You just have to write down what you know and write down what's given, and then look at solving an equation. So I'm actually going to work another problem, but I'm going to make a different video for that. So hope y'all enjoyed it and hope you could understand.